In this presentation, we will see a relation between beta and gamma. We know that 0 to infinity y to the power n minus 1 e to the power minus xy dy is equal to gamma n over x to the power n. We are doing integration with respect to y. Here x is a constant. This formula we have proved in representation 1. Then gamma n can be written as gamma n is equal to 0 to infinity x to the power n y to the power n minus 1 e to the power minus xy dy. This is our equation number 1. Also we can write gamma m is equal to 0 to infinity x to the power m minus 1 into e to the power minus x dx. This is our equation number 2. Multiplying both sides of equation 1 by x to the power m minus 1 into e to the power minus x, then we get gamma n into x to the power m minus 1 into e to the power minus x is equal to x to the power m minus 1 into e to the power minus x integration 0 to infinity x to the power n y to the power n minus 1 into e to the power minus xy dy is equal to 0 to infinity x to the power m minus 1 plus n m plus n minus 1 y to the power n minus 1 into e to the power minus 1 plus y into x dy. This is our equation number 3. On integrating both sides of equation 3 with respect to x, we then limits x is equal to 0 to x is equal to infinity. Then we have dx is equal to 0 to infinity x to the power m plus n minus 1 into e to the power minus 1 plus y into x dx y to the power m minus 1 dy. This is in this integral. Here x is a variable, 1 plus y is a constant. This integral can be written as 0 to infinity gamma m plus n over 1 plus y to the power m plus n into y to the power n minus 1 dy. Gamma m plus n integration 0 to infinity y to the power n minus 1 over 1 plus y to the power m plus n dy. This integral is nothing but beta mn, gamma m plus n into beta m comma n. Here this integral is nothing but gamma m. Therefore gamma m n is equal to gamma m plus n into beta m comma n. We can write beta m comma n is equal to gamma m over gamma m plus n. This is our required equation. Thank you for watching this video. See you in next lecture.